In today's episode of The Art of Engineering, we are going to play with antennas. We're going to ham it hard on antennas. The first thing I'm going to do is have a crack at turning an old TV antenna, a rusty old piece of rubbish essentially, into a VHF, UHF 70 centimeter and 2 meter ham antenna. And the other thing we're going to be doing is I've wanted to create an antenna for the 20 meter band. The original plan was to make it an L, a vertical L with a tuned counterpoise. Now, as I sort of start planning the support structure for this antenna, I'm now thinking I may even be able to do an inverted V that is more east-west than north-south. And that may make the antenna more amenable to DX work. That's what I'm hoping for. That's the ambitious plan for this antenna. Is going to be for 20 meters and it's going to be trapped for 40 meters. So it'll be a 2-band antenna. Let's get on with it. Well, we've managed to sort out our sound problems. I've bought myself a new mic. There it is there. And it actually came with 2 microphones and the Bluetooth module that plugs in the phone. And thus far, I'm really impressed by the sound. It's actually better than the Boya microphone was. And you're probably wondering why I'm on the roof. Well, I'm on the roof because, as you can see, I'll just try and get it in frame. As you can see in the background there, I've got my brand new TV antenna. I was getting a lot of QRN, which for those non-ham folk is static from the wife, because, you know, I was telling her about me having conversations in Morse with people that were thousands of kilometers away. And she was like, well, that's great, but it would be really nice if we could get reception on SBS and Channel 7 for the TV. So I went and bought this new Hills antenna there, and we took down the old Yagi OODA array. And it really shouldn't be called a Yagi antenna. It should be called the OODA antenna, because Yagi kind of stole OODA's thunder. So if you're ever interested in some radio history, go and look up that little saga. It's quite an interesting one. That antenna there now is a log periodic, and it doesn't have the longer elements on it that the older antennas had, because the TV frequencies that were used for analog were a lot lower, so that, hence the larger elements. I'm going to be doing a little bit of fun experimentation with that old antenna, and it might result in a complete piece of rubbish or something that's usable, but it'll be fun finding out. So let's go downstairs and we'll have a look at the old antenna. And here we have the old TV antenna, UHF and VHF. And as you can see, for the lower VHF analog frequencies, you had quite a large element. And so this is a compromised antenna, obviously, and most TV antennas, because they have to cover such a large portion of the VHF, UHF spectrum, tend to be quite compromised. But what I have done is I have got out my old TV splicer and whatnot, and I've put an F connector on there, and it's very badly installed, but hey, it's on there. And on the other end, we have a B and C, because what I intend on doing is running this through the nano VNA and just seeing what frequencies we are dealing with. And then what I'm going to do is, obviously this balun here is going to be a receiving balun, so it's not going to tolerate any high power going through it. So we're going to have to play around with that area there, and we'll find out what the resonant frequency is on the nano VNA, and then we'll decide what we're going to do.
It's up.
The plan now is to get a nano VNA on this, and see what frequencies it's resonant on. That's got to be the best use for a broom I've ever seen. Okay, so the first resonant point you can see there is at 77 megahertz, and the SWR is 1:1.22. Our next resonant point is at 104 megahertz with an SWR of 1.02. Now I'm going to ignore these little ones here, but we'll go through them just to have a look at what they look like. Better hold on to it, I'm going to drop it otherwise. That one's at 2.75, and it's actually a 144 meg resonant point, so you could probably almost run this on 2 meters now. It's probably a little bit too high, but it should be below 2. That one is 189, 2.55, and then we're one is at 2.27 at 261 megs, and then the next low point is that UHF 378.5 megahertz, which is that one there where the balun is. It looks like it's a UHF element, so that would be the that resonant frequency that we're looking at there, most likely at 374. And I think I did a measurement on it, and it was approximately that length. So we need to make that element shorter, and then all I'm going to do is cut that element shorter and just see what this nano VNA trace looks like once I've cut that resonant length for the center of the 70 centimeter band. And then we'll come back and we'll look at this trace. Obviously directors and reflectors need to be cut. Probably spacing is not optimal, but I'm trying to do as little as possible to this antenna and still make it directional and usable. So that's the prepper antenna that I'm using presently, and I can get to local repeaters on that antenna, and there's a video on my channel about the making of that. It's made from a single piece of PVC pipe and some coax cable. What I'm going to do is I'm going to mount my friend here, the junked TV antenna, if it works, and we're going to build a pole, and the pole is going to start down there and it's going to go up above this roof, and that'll be an opportunity also to put up a squid pole that I've purchased. Now we can see on this antenna that at the front here we've got the driven element, which is that one there. You can see the balun going in there, and that driven element has directors in front of it and these 3 reflectors behind it. So this bottom part of the antenna here, mounted on the back here, the reflectors on the bottom of the boom, at the front they're on the top. This part here with the short elements is a Yagi UDA UHF antenna, and then this driven element also forms the front of a log periodic at the back, and log periodics provide directional antennas but also broad bandwidth. And the thing that differentiates this from the Yagi UDA array is the Yagi UDA has all passive reflectors and directors. The only driven element, i.e. the one that has RF on it, is this one here, which is called the driven element in the Yagi, whereas in a log periodic all of the elements are driven, and you can see they're driven from the front if it's a log periodic, and as we go back you can see these crisscrossing wires that cross from one side to the other going all the way back. So each one of those elements is a driven element with a crossover happening. So that's the configuration for this antenna. Now, I was very tempted, and I still may make this a Yagi here, leave it as a Yagi and make it the 70 centimeter part of the antenna, and make this part of the antenna couple into a driven element here, and make this part here a 3 element 2 meter Yagi. But I'm very tempted to play around with trying to leave it in its log periodic format and just see if I can get it to work as is. Now the spacings are probably going to be incorrect and it's probably not going to be the optimal performance, but I want to see what sort of performance I can get out of it without taking elements off the boom, without changing the spacing. All I'm going to do is cut these to different lengths to see if I can get it to dip in the right places, and then we're going to get it up on a support at a reasonable height, probably the same height as my vertical antenna, and see if we can hit repeaters that I'm unable to hit with the vertical. And that's going to be the acid test for this, and then it'll probably come down and I'll do even more work to it. And this is the new antenna support, and we're going to add a little bit of height to that, and hopefully we can get it at approximately the same height as the prepper antenna. Now, any antenna engineers who are watching this are probably shaking their head in dismay and disbelief at the mistakes that I'm probably making. At any rate, I've gone online, and what I've done is I've gone to a Yagi calculator, and I've worked out that I need reflectors that are 34 centimeters, directors that are 30, and a driven element that's 32 to operate on the 70 centimeter band. And then I've basically just looked at trying to get dimensions for an antenna that'll cover from the driven element, which is 32, which will be on the 70 centimeter band, right back to the 2 meter band. Now the spacings are probably going to not be optimal, or maybe not even work for a log periodic. I don't actually know. I don't want to move them for the time being. So what I'm going to be doing is I'll be cutting these elements to these dimensions, and that will give me a log periodic that will cover frequencies that'll probably hop 2 or 3 times back to the 2 meter band. And hopefully that gives me an antenna that operates on both those frequencies. To what end, to what gain, etc., who knows. But we're going to find out by trying it out. And then probably what I will do is maybe play around with changing elements and whatnot. Now the directors on the antenna are very, very short, even shorter than the directors that would be required for 70 centimeters. So I'm hoping that I have enough excess when I cut back this larger element at the back to build new directors for the antenna. I may very well end up with just a very good 70 centimeter antenna, which is fine. I'll just then have to play around with building myself a 2 meter antenna. But I'm still in two minds as to how I proceed, whether I should just do 2 Yagi antennas on the one boom, if that's even a doable thing, on one piece of coax harnessed together, or a log periodic. Still thinking about it. Now I've measured out all my distances. We're going to play with the driven elements later, but we're going to cut as per the original plan, making the back the original log periodic, and the front is going to be a driven 70 centimeter element, and we'll just see how it goes. Now I am using an angle grinder to do this, but unless you know what you're doing or you're confident using that particular tool, hacksaw is probably the way to go. But this will save me a lot of time. And you've probably noticed I've got proper shoes on, which is something that doesn't happen very often, but if you drop this thing, you'd want to try and improve your chances of not losing a toe. And there you have it. A VHF UHF monstrosity. Now we tried looking at this to see what the resonant frequency was, and It was resonant at 180 and up near 500. So completely wrong. So what I've done is I've removed the balun, and this is the driven element now, and the directors were very much shorter than they needed to be. So hey, we've done a real dodgy on that too. We may do that better later on, or we may not. But yeah, we're just trying to see if we can sneak the resonant frequency down to what it needs to be. If this doesn't work, I will be endeavoring to maybe make this driven element a 2 meter element and make the other elements parasitic and see how that works out. But we'll play around with that when the situation requires it. Presently, we'll just keep going with what we've got. Alas, now we have an SWR at 144 of 9.7, and the biggest dip, which is just there, is I think it's around 300 something megs. We'll just have a look. Yes, best match is at 300 megs. At around 430, we're looking at an SWR of 5. So presently, it's not behaving like I would like it to. The joys of homebrew. Now, the VHF UHF TV antenna that I was hoping to turn into a ham antenna, sadly, has met its demise. And we could look at that as a complete failure, but the growth mindset that I'm trying to instill in people that want to take this homebrew journey, and I'm letting you know that there's plenty of people that hit their first hurdle in homebrew and go, this is too hard, and they straight away go out and buy a store-bought rig, and that's the last time they try doing anything homebrew. I would say, instead of seeing the setbacks as frustrations, see them as opportunities to learn. I know I'm sounding like the high school teacher from hell, because essentially that's what I am, but it's really important to understand that these are all opportunities to learn. So in the process of analyzing this antenna, I got to see what a TV antenna looks like on the Nano VNA, and understand why it's a compromised antenna. It had a lot of dips at very different SWRs. It certainly was a very broadband antenna. It probably wouldn't have performed very well on the ham bands, although there was one dip that was close to 2 meters. And had I not destroyed it in the process, I may have actually just tried seeing if I could actually swire it up on 2 meters and see how it goes. But that boat has sailed. In the process of doing the research required to understand these types of antennas, I've come across a ton of resources on people that build their own beams, especially for 70 centimeters and 2 meters, and heaps of designs that are very, very achievable after a trip to Bunnings. So I have not given up on creating a beam. In fact, I'm doubling down on that effort. But in the meantime, I'm going to switch my concentration over to an antenna for 14 megs, and it's going to also double as a trapped 40 meter antenna as well. I'm going to take you outside to the TV antenna and show you what's left of it. Okay. You hungry, are you? No, okay. What I discovered was there's huge amounts of, obviously there's huge amounts of corrosion, but these plastic bits have become very, very brittle because of the sun and whatnot. So um, we might be able to salvage some bits off this antenna, maybe the boom, but yeah, I think I'll try and save the boom on this, but that'll be about it probably. Having said that, if the boom's made out of steel, which I strongly suspect is the case, just for the sake of wind loading and weight loading, I'm probably better off getting all aluminium and PVC piping. There you go, the lorikeets, and playing around with that, making an antenna that's a lot lighter. So it's onwards and upwards. This is the smaller squid pole that was on special, and hence we've made ourselves a support that's a little bit higher. And someone's getting very excited by the bird life. and luckily he never catches any too fat, too old, like me. And that's our support, which we're going to add some timber to. So I'm thinking we can get the center of this next antenna at a reasonable height. And that antenna, of course, is the one we talked about at the beginning, which is the 20 meter and 40 meter inverted V first. And then if I need to, or if I want to, I can then compare it to a more omnidirectional inverted L configuration. But I'm thinking I'll get more benefit from it as an inverted V fed at the center.